All right, everybody. I just finished doing this entire worksheet and it did not pick up my voice. So I'm going to take another crack at it. If I go too fast, make sure you just, you can slow down the video, pause the video, whatever you need to do. And also come to class, even if you've watched it, to get any help that you need. So we got ourselves a trinomial here. We check for GCFs. It does not have any GCF. We can see, and this is important, our coefficient out front is a 1. And that means when we try to find our R and S value, I square that in because that's important. C is 12 here. When we find our R and S value, we just have to use the number that C is. So we're going to list all of the R times S's. Just R and S are just random variables. You'd use any variables you want to. Here's all the things that multiply to give you a 12. 1 times 12, 2 times 6, 3 times 4. We want a pair that adds up to negative 8. Now, none of these right now add up to a negative number at all because they're all positive. So in order to get a negative 8 and at the same time get a positive 12 when you multiply, they're both going to have to be negative numbers. They can't have one positive, one negative, because then they won't multiply to be a positive. Okay? And the only way we're going to get a negative is if we have at least one negative. So we're going to have both negative to get the positive 12, and that can also give us a negative 8. So let's see what they add up to. Now that they're both negative, that's negative 13. When I add these, that's negative 8. When I add these, they add up to negative 7. So we clearly want negative 2 minus the 6. And so now I'm going to finish, and I'll just factor this thing. It's just going to be x plus the r value, which is negative 2, and x plus the s value, which is negative 6. And we are done. Next one, let's look for a GCF. It looks like everybody's divisible by 3, but also an n. So 3 divided by 3, oops. Keep that pencil. So 3 divided by 3 is 1, and then n to the 4th, and I'm taking away one n, so that's n cubed. 6 divided by 3 is 2, and I'm taking away one of those n's, so it's just n. And then lastly, 18 divided by 3 is 6, and n, take away the n, is no n's left. We usually don't show this 1 right there. And we would try to factor this trinomial here, but it's an n cubed, and we've never factored a 3-termer with a cubed in front of it. If that was an n squared, we'd take a crack at it, but it's not, so we aren't even going to waste our time. And we're done. Problem 3 is a little bit different. There's no GCF. 3 and 14 aren't divisible by the same number. Can't take out an x. 3 terms, so we're going to list our A, our B, and we should start to notice patterns here, and our C. The pattern I'd like you to notice is, see how this is negative and this one's positive? That positive sign tells you that the R and the S are going to have to be the same number, or the same sign, and this negative tells you they're both going to be negative. Okay, that's just a little rule of thumb. Now, because our A value is a 3, everybody, we cannot just do the C. We have to take A times C, and that's 3 times 8, which is 24. So there's the product we're looking for. R times S, let's list them all. 1 and 24, and 2 and 12, 3 and 8, and 4 times 6. And they're both going to have to be negative, so that when they multiply, they give us a positive 24, but when they add, they give us a negative 14. So let's just add these up and see what we get. Well, that's negative 25. This is negative 14. This one would be negative 11. And this one would be negative 10. So clearly, we want this pair. They add up to negative 14, and they multiply to positive 24. You do have to be a little careful here as we try to factor this thing now. We can't just go x plus r and x plus s. We have to go ax plus r and ax plus s, which is a negative 12, Now we have to look for a GCF in either one or both. No GCF. Oop, both divisible by 3, so we're going to factor that 3 out. Oops. 3x minus 2. Here comes the 3 I'm pulling out, leaving me a x minus 4. And then you just cancel out that 3 that you pulled out. 3x minus 2 times x minus 4. Of course, we could check this by remultiplying it, but we're not going to spend time doing that right now. Next one, let's look for a GCF. Everybody's divisible by 3, it looks like. And they have at least an x squared in common. So I'm just dividing all these numbers by a 3 and taking 2 x's out of them. So that's 4x squared, reduced it by 2. That's 11x to the first, took away 2 x's. And that's 6, and I took away both the x's. All right, now we're going to do exactly what we just did on the previous problem. A is 4. It's not a 1, so we're going to have to do A times C. B is 11, and C is 6. This time everybody's positive, so our R and S are going to be positive numbers. So let's calculate A times C over here. A times C would be 4 times 6. That's 24. So we got to go for a 24 with our R times S. And we'll list our factors again. 1 and 24, 2 and 12, 3 and 8, 4 and 6. They all multiply to give you a 24. Let's see what they add to. 25, I should say, plus equals. This one, you add them, you get a 14. These, 3 plus 8, sorry, my dog threw me off there. She's out playing with her toy. That adds up to 11. That looks like the one we want. This one adds up to 10. So our B value was 11 right there. Should have put a box around it. I had a hard time finding it. But those two add up to 11, so it meets this criteria. And 3 times 8 is 24, so it meets that one. So and generally what I like to do, because to make it work better, is I usually do my work off to the side and go, okay, so AX plus my R, so plus 3, and 8x plus my S, so that's plus 8. I look for a GCF. There isn't one in the first pair, but there is in the second pair. I cross out the GCF. Here's my final factorization. You have to remember we pulled out this GCF first. It's still part of our problem. Then our factors that we just found, the 4x plus 3, that's way over here, and the x plus 2. And we are done. 5, halfway done, everybody. All right, 2 terms, so it's either a difference, because of the minus sign, difference of squares, or a difference of cubes. This 2 is a big hint that it's a difference of squares. So it's 3x quantity squared minus a 5 squared. That's our A, that's our B, and it's just 3x minus 5, A minus B, times 3x plus 5, the A plus B. That's all there is to that problem. We love differences of squares. 6 we're not so fond of because it's got 4 terms. There is no GCF. The only thing 7 is divisible by is 7, and 4 is not divisible by 7, so we can rule that out. And we don't have an x in everybody. So when you have 4 terms, you're just going to put a pair of parentheses around the first 2 terms. You're going to put a big plus sign, always, parenthesis, and then you have to put that negative inside, like that. So let's now just GCF this first grouping. Okay, I think the biggest number, they're both divisible by, is a 6. And they both have an x squared in them at least. So 42 divided by 6 is 7, and I took away 2 x's. And 24 divided by 6 is 4, and I took away both the x's. In the second pair here, okay, 7 and 4 are not divisible by any one thing, but I can factor out a negative 1, leaving me a positive 7x and a minus 4. So that flipped everybody's sign. This is still negative 7x and plus 4 if I were to redistribute it. But by factoring out the -1, look at how I have these common factors. And so when I yank that out, I pull it out as a single group. Out comes 7x minus 4. And when I take this one, essentially, I'm dividing this whole thing by 7x minus 4. Those cancel. I'm just left with a 6x squared. And I'm dividing this all out by 7x minus 4. They cancel, leaving me minus 1. And I'm done. Okay, so I took the 7x minus 4 out front, leaving me 6x squared minus 1. Now, you might try to factor this second polynomial here. It's a difference. It's only got 2 terms. It's got an x squared. However, 6 is not a perfect square. 3 times 3 is 9, and 2 times 2 is 4. So we can't do a perfect square or a difference of squares. 7 is a straightforward application of the sum of cubes. This is an x that's cubed, and this is a 3 that is cubed. Here's the formula. I will give you these formulas for the quiz. It's a b cubed. And so it is a plus b times a squared minus ab plus b squared. That's just something we can memorize. Our a is x, our b is 3. So we go x plus 3. That says take whatever a is and square it. So ours is an x that we square. That's x squared. Then it says put a minus sign. And it says take a times b. Our a is x, our b is 3, so x times 3 is 3x. And then the formula says take the b value and square it. So b squared, our b value is 3, we square it, and that is a 9. And there we go. We have just factored it. This second trinomial here, don't ever waste your time trying to factor him. He will always be prime when you do the difference or the sum of cubes. Number 8. All right. I've got something to the 4th power here. I'm hoping there's a GCF. I think we can take a 2 out of everybody because they're even. We can take an x out of everybody because they all have at least one x, leaving us with 125. Just divided by 2. Took away one of the x's. Divide by 2, and that's a 64, and I took the x out. So I'm hoping this is a difference of cubes now, and it turns out it is. 5 times 5 is 25, and if you had 5 quarters times another 5, it'd be $1.25, 125, and 4 times 4 is 16, times 4 is 64. So we can rewrite this as a 5x that's cubed. 5 cubed is 125, x cubed is x cubed, and minus a 4 cubed. I'll write down the formula again real quick. The other one was a sum, so this is the difference. Always it starts with the same sign. Square the a. This time it's an addition because you only get one minus sign, and we used it at the beginning. All right, now I'm going to just kind of write the whole answer down here. My final answer, I've got this GCF I took out. Then it goes a minus b, 5x minus 4. Okay, now I figure these next problems out. The a squared, I do it off to the side here. It's a 5x, that's my a, but I got to square it. That's my a squared. 5 squared is 25, and x squared is x squared, so a squared is 25x squared. Next, I have to calculate a times b. A times b will be a 5x times a 4. 5 times 4 is 20, so that's 20 x's. And then lastly, I have to calculate b squared. My b is a 4, and I have to square it, so that's a 16, so I put plus 16 at the end. And that is the complete factorization. Problem 9. Find him up here. This is what we just practiced on Tuesday, just the other day. How do I prove something's a factor? I do division and see if it goes into it evenly. So I'm dividing by this binomial. Okay, it's x minus 1, and we always use the opposite sign when we do synthetic. So if it's x minus 1, I'm putting a positive 1 in the box. Here's my coefficients. I got 1x cubed. I've got negative 1x squared. I've got a 2, and I've got a minus 2. I've got all the terms, 3, 2, 1, none. Okay, so I don't have to put any zeros for fillers. So I'm writing those coefficients down. Skip a line, draw a line, and here we go. Drop 1, multiply. 1 times 1 is 1. Add them up, 0. 1 times 0 is 0. Add them up, that's 2. 1 times 2 is 2. Add them up, 0. Bam. It's a factor, all right. Okay, so we just say yes. X minus 2 is a factor. Since the remainder equaled 0. Pretty straightforward. And our last one, number 10. It looks like I'm going to have to do a little erasing here. I don't know what. That didn't erase. Problem number 10, same type of thing, except we have to now not only show that x plus 4 is a factor of this huge polynomial, but then we've got to do one more step and try and get it completely factored. So we're going to divide out x plus 4. To do that, we put the negative 4 in the box. Coefficients, 2, x to the 4th, 6x cubed, negative 5x squared, 9 x's, and minus 12. Looks like a long problem. It's not too bad, especially if the remainder is going to be 0, so it's always going to be numbers that combine nicely. Negative 4 times 2, negative 8, add them up. Negative 4 times negative 2, positive 8, add them up. Negative 4 times 3, negative 12, add them up. Negative 4 times negative 3 is positive 12, add them up, bam. Remainder is 0. Now the cool thing is you've actually accomplished 2 tasks. You, see if we can just move that guy, there we go. You not only found out that x plus 4 was a factor, you've actually started to factor f of x. F of x has a factor now that is x plus 4, and the other factor is the answer to the division problem. Now, we started with x to the 4th, so it always goes down by 1 degree. So now it's an x cubed, an x squared, 3x minus 3. So that is the other factor. It's the same thing we do. We saw this. If I had 6 divided by 2, it gives me 3, and therefore 2 times 3 is 6. The polynomial divided by x plus 4 gave me this, and therefore x plus 4 times this, the quotient, the answer, would give me the original polynomial. Now, unfortunately, we got to check to see if we can still factor this guy. And he's got 4 terms in him, so we're going to try the grouping method. All right, so let's write him down in groups. We have 2x cubed minus 2x squared, big plus sign, and then our second group, 3x and minus 3. Let's look for a GCF, both divisible by 2, and both have an x squared in them. So let's pull out that x squared as well, leaving us with an x. And here when I divide 2x squared by 2x squared, because that's what I'm taking out, that becomes a 1 right there. Same thing happens on this second one here. When I divide out a 3, I divide by 3, leaving me with an x. I divide by 3, leaving me with a negative 1. And so there's our common factor, x minus 1. We yank that guy out front, and we're left with a 2x squared plus 3. Now that is not our final answer, because remember we had this x plus 4 that we already knew was a factor, so we got to put him down here too. So f of x in its factored form is the product of these 3 binomials. And now we are